I am K. Narsimurthy, working as an assistant professor in the Government First Aid Women's College, Tumkur. Today I am going to present the video for the course BSc, and the paper subject is physics. And the paper which I am discussing is semiconductor devices, digital electronics, laser and the fiber optics. That's the title of the paper which I am discussing. In that paper I am going to discuss the topic AND and OR gates. Alright. So we are going to learn about the AND and OR gate definitions, truth tables and symbol. Along with that, we are going to realize the AND and OR gate using diodes. So before going to the AND gate, you should know what do you mean, what's the meaning of logic gates. Logic gate is an electronic circuit which performs logical operations, which takes logical decisions. It is nothing but an electronic circuit which performs logical operations. Any logic gate has 2 or 3 inputs and a single output, except one gate, that is NOT gate. In the case of NOT gate, it has only one input and one output, except that all other logic gates has 2 or more inputs and only one output. So we have different kind of logic gates, namely AND gate, OR gate, NOT gate, NAND gate, NOR gate, XOR gate, XNOR gate. These are the different kinds of logic gates we have seen. In that different kind of logic gates, the very basic gates are AND gate, OR gate and NOT gate. These 3 gates are the very basic gates. Apart from these 3, all other gates are derived gates. All other gate means the NAND gate, NOR gate, XOR gate, XNOR gate. These are all the derived gates. We have 2 categories. One is the basic gates, another is the derived gates. Now today we will discuss only the very basic logic gates, AND gate and OR gate. So here AND gate has 2 or more inputs and only one output, single output. AND gate output is high only when all the inputs are high. This is the only definition we can give it for AND gate. It has high output only when all the inputs are high. When you look at the truth table, you will understand this definition better. Look at the symbol of AND gate. This is the symbol of AND gate. This is the symbol of AND gate. We have only 2 inputs, 2 terminals, 2 inputs A and B, and we have only one output, that is Y. Y is equal to A dot B. It performs logical multiplication. AND gate performs logical multiplication. It's called AND function. It is called AND function. It's a kind of logical multiplication. That is why we represent it as Y is equal to A dot B. Means this is logical multiplication. So it has one output and the 2 inputs which are A and B. And we have a truth table here. What do you mean by truth table? So truth table contains the performance of logical circuit. It contains all the performance of logical circuit. It contains input values and the corresponding output values. It contains the values of 2 inputs A and B, and it contains the corresponding output value, that is Y. And also here we have to understand what do you mean by 0 and 1. 0 here in the truth table means it's an half state, or you can say low. Low voltage. Low voltage state is 0 state and high voltage state is 1. 1 is represented as a high voltage state. So that is the truth table. We have a truth table for AND gate. We have a different combinations of inputs. The first combination of input is 0, 0. When we look at this combination for 0, 0, means input A is also 0, input B is also 0, output is 0. Look at the second combination. Input A is 0, and input B is 1. We are giving the input for B now. But even if we give the input for B, output is 0. Look at the third combination. We are giving the high voltage to the input A, that means 1. And we are not at all giving any input to the B. But still the output is 0. Look at the last combination. We are giving input to both A and both B. We are supplying a high voltage for both input A as well as input B. For that combination, you will get the output as 1. Why is 1 here? For the last combination, that is 1, 1. A is 1, B is 1. Then only you will get output as 1. That is the only way we define AND gate. As I defined earlier, AND gate as high output, high in the sense 1. High output only when all the inputs are high. All the inputs in the sense A should be 1, B should be 1, then only Y will be 1. Okay, so that is the precise definition of AND gate. Now we build the AND gate using the diodes. That means we realize the AND gate using the very basic diodes. So these are the circuit which is built with the diodes to perform AND operation. Okay, we have used the two PN junctions diodes. Okay, this is the diagram which shows the realization of AND gate using the diodes. So this figure consists of two PN junctions diodes, where A and B, these are the two inputs which are connected to cathode terminal, that means positive terminal. So A and B are connected to the cathode terminal and the anode is connected to plus 5 volts. We are giving a plus 5 volt separate voltage to the anode terminal of these two diodes. But when you come to the case of diode, you need to understand what is forward bias and the reverse bias is. In the case of forward bias, if P type is connected to positive terminal of the battery and N type is connected to negative terminal of the battery. But whereas in the case of reverse bias, P type is connected to negative of the battery and N type is connected to positive of the battery. But in the forward bias, the diode conducts, and in the reverse bias, the diode will not conduct. But you may be confusing which is P type and which is N type. Look at the diode symbol. There is a vertical line in the diode symbol. This vertical line represents N type. And the other terminal is obviously the P type. Okay. So be careful. The vertical line is N type and the other terminal is P type. Now we will realize the AND gate using this kind of circuit. Okay. So we will go through the different combinations of input and we verify whether we are getting the correct output of AND gate or not. The first combination is 0, 0. If both A is 0 and B is 0, look at the P type. P type is connected to the plus 5 volts here for both the diodes. P type is connected to the plus here and the N type is connected to 0 means it's a negative state. Here also N type is connected to the negative state. That means both the diodes are under forward bias. For 0, 0 case, both the diodes are under forward bias. That means both the diode conducts. Both the diode conducts means here there is a voltage drop across the resistor. There is a voltage drop across the resistor. So you cannot see any voltage at the output terminal. Okay, because both the diodes are in conducting and the voltage goes here and there is a voltage drop across this. So you cannot see any voltage. Right, for the second and third combinations, 0 and 1 and 1 and 0, if I analyze 0 and 1, 1 will be under forward bias and 1 will be under reverse bias. If it is enough that one diode will be under forward bias to make the voltage drop across the resistor. If A is under forward bias, there will be definitely the voltage drop across the resistor. You cannot see any voltage across the output. Suppose if B is under the forward bias, so definitely there is again a voltage drop across the resistor. You cannot see any voltage across the output. It is enough that one diode conducts. That means there will be a voltage drop across the resistor. The output is obviously 0. Look at the fourth case, the fourth combination, that is for 1, 1. If A is 1 and B is 1, so 1 means plus 5 volts. In the case plus 5 is connected to negative terminal, means N type. Here also plus 5 is connected to N type. That means diodes are under reverse bias now. For 1, 1 case, for high, high case, both the diodes are under reverse bias. Both the diodes will not conduct. If both the diodes will not conduct means voltage, there won't be any voltage drop across the resistor. Therefore, all the voltage is seen at the output. Okay. So this is how we can build an AND gate. This is how we realize the AND gate using the two simple PN junction diodes. That is what I have explained in this slide. We move on to the next gate, that is OR gate. So OR gate performs OR operation. It's a kind of logical addition. The OR gate has two or more inputs and only one output. As it's same as the AND gate. The input and output, number of input and output terminal is same as that of the AND gate. Two or more input terminals and only one output terminal. In the OR gate, the output is high if any or all the inputs are high. That's a very unique character apart from the AND gate. Here you will get a high output. If any one of the input is high, that's enough. Or if both the inputs are high, that's very good to make the output high. Okay. So this is the symbol of OR gate. Two inputs A and B and only one output. You can represent it as C or you can represent it as Y. Nothing matters. C is equal to A plus B because it's a logical addition. Again, we are representing the same combinations of input and the corresponding output in the truth table. So these two are the inputs and this is the output. It is A plus B. Okay. So look at the truth table. When you will get the high output, you can only get the high output if any one of the input or both the inputs are high. It is sufficient that one input is high to make the output high for OR gate. Okay, now the thing is to realize these OR gate using diodes. Of course, you can realize these kind of basic gates, AND gate and OR gate using transistors, but that is not in the syllabus. So we are doing only the realization of AND gate using diodes. It's a very simple to realize with the diodes. So again, we have used very simple two PN junctions diodes. But one thing which is different from the AND gate realization here is we are not giving any supply voltage here. No external supply voltage. No positive plus 5 volt through a resistor R. Okay. So we have no any supply voltages. We are only two inputs A and B. Two inputs A and B are connected to the two diodes. And here is an output. Of course, we have a resistor and the ground here. Okay. Right. If input voltage at the point A and B are low, both the inputs are low, means the first case. The first case of the truth table where A is 0 and B is also 0. In that case, all the diodes are non-conducting. All the diodes means two diodes. These two diodes, because here is 0 is connected to P type. And here also 0, which is connected to P type. If 0 is connected to P type, it is reverse bias. If 1 is connected to P type, it is forward bias. Be careful. So now with the first combinations, both A is 0, B is 0, both are connected to the P type. It means to say both the diodes are under reverse bias. It means both the diodes will not conduct. If both will not conduct, here is the supply we are giving. Both will not conduct means you cannot expect any voltage at the output. Output voltage will be 0. Okay, look at the combinations of second and third combinations where any one of the input is high. If one of the input is high, either A is 1 or B is 1, in that cases, if A is 1, this diode will be under forward bias because 1 is connected to P type. This diode D1 will be under forward bias. This diode conducts. So you can expect an output voltage for the second combination. So output voltage will be high for the second combination. Look at the third combination where B is 1 and A is 0. In such a case, this diode D2, P terminal of the diode D2 is connected to 1 here. So diode D2 will be under forward bias. So this D2 conducts. If it is enough if 1 conducts. So here the D2 will conduct. So therefore you can observe an high voltage at the output. For the third combination also we are getting an high output. Look at the last combination 1 1. A is also 1, B is also 1. In the last combination, both the diodes will conduct. A will also conduct, B will also conduct. If both the diodes conducts, both the diodes under forward bias, they will conduct. So it is enough that you will get an high output. So all the three cases except first case, that is for 0 0, you will get high output voltage. So in the OR gate, you will get high output only if any or all the inputs are high. That is the definition of OR gate. So today we have learned both the gates, both the basic gates, AND gate and OR gate, and we realized both the gate using diodes, very simple diodes. And these are some of the good books which I have referred, and you can also go through these books as well. So this is the fundamental principles of electronics by Vasudev Ghosh. Okay, it's published in the 2014, and this is the fundamentals of physics for Tumkur University, and it's published in 2019. And the Malvino and Leach, this is a very old book of digital principles and applications. It's a very, very old book. It's published in 1991. It's a very, very old book. It's a good book. And also one more old book which is published in 2011 is by Sundararajan. It's in fact a very good book, but very few concept of digital electronics was given in the college physics by Sundararajan. Of course, the open sources in the internet also you can get a lot of sources, but you have to be very careful with the internet. Some of the things may be wrong in the internet, but you have to be, while choosing the content in the internet, you have to be very, very careful. Okay, so some of the internet contents which I have taken, and these are some of the references which I have quoted. I hope you understand all the elements of AND gate and OR gate better. Thank you very much.